Avery Fiore, the SAS VEX captain at the time this video is being recorded, and this is the VEX mechanisms course. In this video, we're going to talk about different drivebases or drivetrains. Okay, so here we're starting with the most basic of the four drivebases I'll be talking about today, which is the tank drivebase. How this drivebase works is we have four wheels, each in the corner, pointing in this direction as shown. These two wheels on the left are grouped together in the code, and these two wheels on the right are grouped together in the code, meaning that whenever, say, this top right wheel spins forward, this bottom right wheel will also spin forward. So when it comes to just driving forward, right, all the motors spin forward to push the drivebase forward. And say you wanted to turn, you could just make the right side go backwards while the left side goes forwards, and that would turn the robot clockwise or to the right. So some variations of this drivebase are that you could use either 4 motors, as shown, or you could set it up so that you only use 2 motors, because let's say, there's an 8 motor limit in VEX Robotics, and let's say you need to use more motors for your mechanisms. Then you could just choose to forgo maybe the front 2 motors and use the back 2 motors. Okay, and this would still let you have all the functionalities of this normal tank drivebase, but because you're using fewer motors, the drivebase will overheat faster. And once your robot overheats, especially if it's in a very important part of the robot, like the drivebase, it will just stop working, and you'll have to wait for it to cool down. So it's not advisable to do it, but if absolutely necessary, you could reduce the number of motors in your drivebase to 2 with this tank drivebase. Another variation of the tank drivebase is, right now we have omni wheels in all the corners. And why we use omni wheels generally is that they have these smaller wheels on them. And this lets the wheel slide side to side. Like you can imagine, I can push this wheel left and right now. And so by using omni wheels, it allows the robot to turn very easily. Okay, but let's say an opposing robot tries to push you from the side in this direction. It will be able to right now because there are omni wheels in all the corners. So that isn't always the best thing. And so something that some teams will do is that they will replace maybe the back 2 or the front 2 wheels with traction wheels. And I have traction wheels shown here on the left. They're just like the standard wheel that you're probably more used to. You never want to put traction wheels in all the corners because that will just make your robot skid when it tries to turn. There's too much friction between the wheels, because imagine you try to like drop 4 points in the ground and they all have to work against each other while the robot's trying to turn. Okay, so you always want to use at least 2 omni wheels, but you could choose to make the back 2 traction wheels so you don't get pushed from the side. But it will shift the center of turning. So right now, because these are all omni wheels, center of turning for this robot is where my mouse is right now on the screen line around here. Okay, but let's say these back 2 wheels became traction wheels, then the center of turning would be shifted around here between the 2 traction wheels.
Something else that I want to talk about is how you can vary the speed and torque in a drivebase. And well, this applies to really all the drivebases covered in this video. And the speed and torque of a drivebase is not only dependent on the gear ratio, it's also dependent on the wheel diameter. The larger the wheel, the higher top speed, because if we think about it, for every rotation, the circumference of the wheel is covered for that rotation. So if you have a bigger wheel, the robot will cover more distance and therefore per rotation, and therefore is faster compared to a wheel that is smaller. And well, like in gears, when there's an increase in speed, there's a decrease in torque. There's always this trade-off between torque and speed. And another interesting about drivebases is that the higher the torque you have, the faster the acceleration of the drivebase. So, I don't know. We found that so far in VEX, the wheel sizes that work depending on what you want, or like a 4-inch wheel or a 3.25-inch wheel. Let's say you want to favor more acceleration, or you want to be able to push around your opponents because you want more torque, then you use a 3.25-inch Omni wheel. But if you want to have your robot have a higher top speed and be able to move around the field quickly, though keep in mind that it would have a slightly slower acceleration than a 3.25-inch wheel drive base, then your 4-inch wheel drive base is what you want to use. Okay, and well, I mean, there's gearing itself, right? You can create a gear ratio. You have to make a tiny gearbox here, probably move the motor out a bit so you can set up some gears here, or maybe you move the C channel to the left a bit more, and then you put some gears where my mouse is right now, and then you can gear the drive base. And what's recommended for gearing the drive base, I mean, like I said, it depends on your wheel diameter. But let's say you're using a 4-inch wheel, usually at 200 RPM using a green cartridge motor is fine on its own. You can gear, though it should be tested if you're giving your drive base enough torque to not overheat. But you could try a 3 to 5 gear ratio. That sometimes works. If you're using a 3.25-inch Omni wheel, it's usually considered to be a bit slow, so people will account for this by using a 3 to 5 gear ratio to increase the speed and reduce the torque a bit. Just make the drive base more balanced. And I mean, sometimes you have a different reason for changing the wheel diameter. Maybe you want your robot to be a bit lower profile, then you use a 3.25-inch wheel. Or if you're fine having a higher profile robot because we have more 4-inch wheels in the lab, then just make your drive base with 4-inch wheels.
Pros of this drive base, it's very simple. Basically it, I guess. Cons are, well, depending on your variation, you're not going to, you might get pushed easily from the side, and also it doesn't quite have as many maneuverability functions as the other drive bases that we're going to take a look at. But it's a solid drive base. It works pretty well. Like last year, all the teams made a tank drive base because maneuverability is not always the biggest concern, and you just want solid functional drive base. The tank drive base is the drive base to use. Okay, so now we're going to move on to the next drive base. This is the H drive base. So how this drive base works is you kind of take a tank drive base, but you have to make sure all of the wheels used in H drive base are Omni wheels, and then you add on a 5th wheel that goes across the robot like so. And what this allows you to do is, well, let's take a top view, right? And let's say you want to slide the robot left and right. Well, because we have this other wheel here now, we're able to do that. It lets you, it lets you slide left and right. Some variations of the drive base are that you can either use 5 motors, as shown in this configuration, or like the tank drive base, you could just maybe remove the front 2, or the back 2 motors, and use fewer motors on this drive base. So some pros of this drive base, it gives you this extra maneuverability. You can slide your robot left and right. Some cons of this drive base, because you have to use all Omni wheels. That's just how it works in a H drive base. You have to use all Omni wheels. It will be easier for your opponents to push you around from the side. And this drive base uses additional motors compared to the tank drive base, which might not be the best thing if you need to use motors for other mechanisms in your robot. So now we're going to move on to the third drive base, the Mecanum drive base. Okay, the Mecanum drive base is kind of set up like the tank drive base, but it having 4 motors and it having 4 wheels in the corner. But because we're using these special wheels called mecanum wheels, we're actually still able to traverse left and right, even though we don't have this center wheel from the H drive base. And it's hard for me to really explain this, so I'm just going to show you a video of it in action. This website will also be linked in the YouTube video's description, but this website has some additional drive bases that I don't cover, and if I don't cover them, that's probably because I think they're kind of useless. Like this drive base down here, never build this, but yeah. So we take a look, right? Because these wheels have these slanted wheels on top of them that are at 45 degrees, it allows the robot, depending on how you spin the motors for the robot to traverse side to side. This diagram here depicts this more clearly, and it's interesting. So clearly this robot, I mean, it can traverse side to side, and it doesn't use as many motors as the H drive base. So those are the pros. So why would someone not use this drive base? Well, one small thing is if we look at the H drive base, it's lower profile. These wheels aren't as wide. Sorry, if we use the tank drive base, the wheels are lower profile and not as wide. And if we look at the mecanum drive base, these wheels are a lot wider. And sometimes this matters because you might need space between these two motors to take in some kind of game element. Okay. Another con of this drive base is that when you try to use it to traverse left and right, it's not very efficient for your motors, and it causes them to heat up very quickly just because usually there's a lot of friction while this is done. So you'll be able to traverse left and right, but if you do it too much, your robot's going to overheat, and then it becomes useless, and that's not a good thing. And you especially don't want your robot overheating in the middle of a match. So, I mean, sometimes there's niche cases to use this drive base, but generally speaking, almost none of the teams do, just because the friction problem makes the drive base too inefficient and heat up way too quickly for it to be useful enough. So another drive base that is used sometimes, like used more than the mecanum drive base, it still uses 4 motors and has all of the functionality of being able to traverse in all directions, is this drive base called the X drive base. This one is not very a standard X drive base. Like, you should ignore this thing. This thing doesn't exist for the sake of this tutorial, but if you are wondering, this is a localization module that allows you to track how far the robot moves. But for the explanation of drive base, just pretend these 3 wheels are not here. Okay, so in X drive base, we have these omni wheels turn 45 degrees in each corner. Okay, and say you want to go forward. This wheel turns, if I look at it from this angle, clockwise, right? This wheel turns anti-clockwise, this wheel turns anti-clockwise, and this wheel turns clockwise, and that would actually push the drive base forward. And you can think about this logically and change the direction of the different wheels to accomplish traversing in any direction with this drive base. Okay. So the pros of this drive base is it still uses 4 motors and it has very good maneuverability. Cons of this drive base. It's very difficult to build. You'll have to check out a different video on making these custom plates for VEX Robotics in order to build an effective X drive base. So it's very complicated for the beginner team. And also, this drive base, like the H drive base and the mecanum drive base, because it's using these low traction wheels, opponents will be able to push you if they ram into your robot from the side. Okay, and unlike the past 3 drive bases, because of the wheel setup in like a tank drive base, let's say you're driving forward and backward, you have decent pushing force when you try to ram into opponent, right? But because these wheels are not really optimized to drive in any direction, because let's say you're trying to go 45 degrees at this angle, right? You're actually only using the power of two motors when you go that direction. And let's say you're going straight on, all of these wheels are turning, but they're not turning in a straight path towards that direction. So you'll have not that much pushing force, and you won't really be able to push around your opponents if you use an X drive base.
Something else to point out about the X and the cam drive bases are that when programming them, it can get pretty complicated because you're trying to program the robot so that no matter which direction you point the joystick, the robot drives in that direction. So you point it right, yeah, it'll traverse to the right for the mechanism or just shift to the right in this X drive base. But let's say you wanted to go a very specific angle, like 30 degrees this way that my mouse is moving towards. Well, do that, you need to use trigonometry and write a few more lines of code compared to the tank and H drive base to make this actually work. For H drive base, usually it's a bit simpler because usually you just program it to work like the tank drive base, have that normal setup, and then just use one additional set of buttons on the controller to control the traversing wheel that lets you shift left and right. But you can't really program it that kind of way with the X and the cam drive base, so it becomes more complicated.
So that's the tutorial for drive bases.